Today we are going to discuss MCQs of chapter number 3, Kinetic Theory of Gases and Radiation. First MCQ, in an ideal gas, the molecules possesses only kinetic energy, both kinetic energy and potential energy, only potential energy, neither kinetic nor potential energy. Answer to this question is only kinetic energy because in an ideal gas, all the molecules are in a state of random motion, and if something having though very small mass and are in a state of motion, so it possesses kinetic energy. Therefore, answer to this question is only kinetic energy. The mean free path lambda of a molecule is given by mean free path formula for lambda is 1 upon root 2 pi d square n upon v, where this n upon v term is number of molecules per unit volume. It is denoted with small n. Therefore, formula for mean free path lambda becomes 1 upon root 2 pi d square into small n. So answer to this question is option C. Third MCQ. If pressure of an ideal gas is decreased by 10% isothermally, then its volume will be. So these are the options. First of all, the isothermal means temperature capital T is constant. We know that ideal gas equation PV is equals to N into R into T, where N is the number of molecules per unit volume, R is ideal gas constant, T is temperature. So already these two terms are constant, T given is constant, therefore the product PV is equals to constant. So in this equation, if pressure increases, up arrow indicates increase, volume of a gas decrease, so ultimately the product P and V comes out to be constant, and vice versa, that is if P is decreased, that is pressure is decreased, volume has to increase, so the product PV comes out to be constant. So let us generalize it for two different cases. P1 V1 is equals to P2 V2. We are given that if pressure of an ideal gas is decreased, it means that this P1 is the original pressure, P2 is the new pressure which has been decreased by 10%. So suppose it is 100%, then it is decreased by 10% means P2 is 90%. 100 minus 10, that is 90. 90% of original pressure P1. Therefore, P2 by P1 is equals to 90%. 90% will be expressed as 90 divided by 100. Okay, so this is P2 upon P1 ratio, that is 90 divided by 100. Now, let us take an equation of Boyle's law. P1 V1 is equals to P2 V2. We are asked to find volume V2 by V1, which can be written from this equation as P1 upon P2. Therefore, from this equation, P1 upon P2 can be written as 100 upon, it is reciprocal of this because it is P2 upon P1. So P1 upon P2 will be 100 by 90, comes out to be 10 by 9, it is 1.111, it is recurring. Now as the pressure, new pressure, that is P2 is decreasing. As P2 is decreasing, corresponding volume V2 must be increased. So increase in volume will be calculated from this equation as V2 minus V1, that is the new volume minus original volume divided by original volume, will be from this equation just like this, V2 minus V1. The numerator is 1.111 divided by 1. it will be 1.111 minus 1 divided by 1, it comes out to be 0.1111. So this is increase in volume. It will be V2 minus V1 in terms of percentage. It will be calculated. It has to be multiplied with the 100. This number has to be multiplied with the 100. So it comes out to be 11.11%. So that is the answer D, that is increased by 11.11%. Now next question, it is based on coefficient of absorption, coefficient of reflection is given, and we are asked to find coefficient of transmission. So we know the relation A plus R plus TR equals to 1. We are asked to find coefficient of transmission, which is equals to 1 minus A plus R, which is equals to 1 minus A plus R is 0.72 plus 0.24. It is equals to 1 minus 0.96. It comes out to be 0.04. Therefore, coefficient of transmission will be 0.04. That is option B. Okay, next, the ratio of emissive power of perfectly black body at 1327 temperature and 527 degree centigrade temperature is there is a relation which express the relationship between emissive power. Let us denote this emissive power of perfectly black body as P, directly proportional to T raised to 4. So generalizing it for two different temperatures, the emissive power of a perfectly black body 1 to emissive power of perfectly black body 2 is equals to T2 raised to 4 by T1 raised to 4, which is equals to, it can also be written as T2 by T1 is equals to T2 by T1 whole bracket raised to 4. Now let us number this equation as 1. Now focus on the data. Data given is T1 is equals to 1327 degree centigrade. Converting it in terms of degree Kelvin, we need to multiply it with 273, which will be 1600 degree Kelvin, and T2 will be 527 degree centigrade. Adding 273 into it will get converted into degree Kelvin. So this will be 800 degree Kelvin. Substituting these two values here in equation 1. So the ratio of emissive power of perfectly black body 1 to emissive power of perfectly black body 2 will be 1600 divided by 800 whole bracket raised to 4 will be 2 raised to 4, that is 16. Nothing is in the denominator, so there will be 1. So it will be P1 is to P2 equals to 16 is to 1. So this is the option B. Thank you. That's all for the MCQs of chapter 3.